Okay, this is the video for pre-calculus, finding the x and y intercepts of a function. So first, let's just talk about a fact. A point is an x-intercept if and only if its y-coordinate is 0. Right? That should make sense. Like if I have a graph, suppose I have a graph that's like has several x-intercepts like that, right? Well, if you look at all of these points that cross the x-axis, like here and here and here, here and here, what do they all have in common? This point has coordinates something comma 0. This point also has coordinates something comma 0. So does this point, so does that point, so does this point, something comma 0. They all have a y coordinate of 0, right? So to find the x-intercept or intercepts of any function, you just set y equal to 0 and solve. That's all there is to it. So, for example, suppose I have a function like f of x equals 2x plus 16 over 5x plus 8, or something like that. Okay? If I want to find, if the directions are to find the x-intercept, or intercepts. Okay, if that's the directions, then all I need to do is set y equal to 0. Well, here there's not an actual y, but you know that f of x is just a fancy way of writing y. So really, when you see f of x, you could just replace it with y. So this is really just saying y equals 2x plus 16 over 5x plus 8. So if you're setting that equal to 0, remember, a fraction is equal to 0 whenever the numerator is 0 and the denominator is not, right? So you could simplify this considerably by just setting the top equal to 0. And then just make sure when you're done that the bottom doesn't equal 0 at that point, and that corresponds to an x-intercept. So in this case, you get 2x equals negative 16 and x equals negative 8. Right? And you can definitely tell that negative 8 doesn't give you 0 denominator. So the x-intercept is the point negative 8, 0. That's it. There's only one in this case. Okay? So if the function was a little more complicated, it's still done the same way. Like, for example, if I had something like, let's say it was something like y equals 3x squared minus 12x minus 63 over x squared minus 6x minus 7. Okay, this factors, right? The top factors, there's a common factor of 3, and then you have x squared minus 4x minus 21. Bottom factors 2, but I'll factor it after when I factor this trinomial at the same time. So the top we have 3 times x minus 7 times x plus 3. In the bottom, I have x minus 7 x plus 1. And you might be wondering, like, why did I factor the top or the bottom when I don't have to factor the bottom? Well, remember what I said up here. It's an x-intercept if the numerator is 0 but not the denominator. So in this case, if I set the numerator equal to 0, I get x equals 7 and x equals negative 3. However, at 7, I also get 0 denominator. So even though I got 7 as one of the zeros of the top, it's also a 0 at the bottom, so you have to sort of eliminate it as being an x-intercept point. It's not an x-intercept point. Negative 3 is the only x-intercept point. So the answer here is negative 3, 0. If you put 7, 0, it's wrong because the point 7, 0 isn't even on this graph. If you substitute 7 in, the y-coordinate is undefined. It's not 0. Okay? So that's the bottom line. To find x-intercepts, you set the function equal to 0 and make sure that you don't get 0 denominator anywhere in the function as well. Okay? The next thing then is to find y-intercepts. And the idea is exactly the same. All right? So here's a fact. Fact. A point is a y-intercept if and only if the x-coordinate is 0. Right? Same idea. If I have a function and it has a y-intercept like that, this y-intercept has coordinates 0 comma something. I don't know what that something is, but it's 0 comma something. And that would be true no matter what, right? If I had any function that crosses the y-axis, that point has to have an x-coordinate of 0. So to find the y-intercept, now there really can't be more than one if it's a function, right? Because if it's a function, it has to pass the vertical line test. It can't cross through the y-axis twice. But this general way of finding y-intercept works for non-functions too. Like it would work for the equation of a circle or the equation of an ellipse or something like that. So I'm just going to say to find the y-intercepts, although we know that if it's a function, this is not going to be plural. All right. So to find the y-intercepts of, instead of saying a function, I'll say of any curve. You're just going to set x equal to 0 and solve. That's it. Okay. So if I have a function, piece of paper. If I have a function like f of x equals x plus 8 over x minus 3. I really just need to find the points where x equals 0. So y would equal 0 plus 8 over 0 minus 3 is negative 8/3. That's it. If the directions were to find the y-intercepts. Okay, now writing it as a point, you'd have to write it as 0, negative 8/3. That's the actual point. That's the y-intercept. So you got to be careful when you're entering it into delta math. You got to enter it that way. Okay, if it was something like f of x equals x plus 4 over something like x squared plus 9x minus 12 or something. Same idea. Y would equal f of 0, which is 0 plus 4 over 0 plus 0 minus 12. The answer is negative 1/3. So the y-intercept is 0, negative 1/3. Okay. Another one. How about something like f of x equals 3x squared minus 6x over 5x minus 10. In this case, f of 0 would be 0 minus 0 over 0 minus 10. The numerator is 0. The denominator is negative 10. If you have a fraction in which the numerator is 0, that's okay. The answer is just 0. It's the denominator being 0 that's problematic, right? So in this case, 0 is the answer. So the answer would be 0, 0 is the y-intercept. Okay, one more example. If it was something like f of x equals x squared plus 8x plus 7 over x squared plus 7x. Okay, if I set x equal to 0 in this case, I get 0 plus 0 plus 7 over 0 plus 0, which is 7 over 0. This is undefined. So the answer here would be there's no y-intercepts. Okay? Because there aren't any points that give you a 0 numerator and a non-zero denominator in this case. Wait, other way around. Sorry, that's to find x-intercepts. If you substitute in x equals 0, you don't get a defined number. And that's it. All right, thanks for watching. See you tomorrow.